Okay, dear students, in the last class we discussed about various atomic models proposed by various scientists, but all those atomic models were failed to explain the complete structure of the atom in relation with the that is spectrum. So therefore, the new model proposed, that is the vector atom model. So in order to explain the complex spectra of atoms and their relation to the atomic structure, vector theory is used. Hence, this is known as vector atom model. The two main features of the vector atom model are space quantization and the concept of electron spin. So let us study what is space quantization. If you understand the space quantization, you will understand that is atomic spectra. So therefore, let us see what is space quantization. Space quantization, in which space, in the sense the space which is present around the that is nucleus. Suppose this is the nucleus, and if you assume there are no electrons, then there are no orbits. So therefore this is called the space. Then quantization. Quantization means the discrete orientation of the orbits around the that is nucleus. In the sense, here what are the orbits oriented? Those orbits have the fixed size, fixed form, as well as the number of electrons in an individual orbit are fixed, as well as the angular momentum of those electrons in these orbits are fixed. Also, the magnetic moment due to these orbits are also fixed, along with the spin motion and spin magnetic moment of these electrons in the orbits are fixed. So hence it is known as quantization. In the sense, for example, if you take an atom, in first orbit only 2 electrons, and it is always 2 electrons only, they have a fixed angular momentum in a one particular direction and spin motion in a particular direction, as well as their velocity. All these things are fixed. If you go for a second orbit, there are how many electrons? 8 electrons are there, and their position, their velocity, their angular momentum, all this is fixed. Okay, and this atomic model is universally constant. If you take any element, the structure of the atom doesn't change. Only the number of electrons in an atom changes, but the structure of the atom remains same. In the sense, that is the first orbit whose radius is constant, second orbit whose radius is constant, as well as the angular momentum in the first orbit electron is also constant. So that is the discrete orientation of orbits around the nucleus is known as the space quantization. ಕನ್ನಡದಲ್ಲಿ ಹೇಳಬೇಕಂದ್ರೆ that is ಆರ್ಬಿಟ್ಗಳು ಉತ್ಪತ್ತಿಯಾಗುತ್ತವೆ. ಆ ಉತ್ಪತ್ತಿ ಹೇಗಾಗ್ತವೆ ಅಂದ್ರೆ ಅದಕ್ಕೊಂದು ಕಂಡೀಷನ್ ಇದೆ. ಪ್ರತಿಯೊಂದು ಆರ್ಬಿಟ್ ರೇಡಿಯಸ್ ಫಿಕ್ಸ್ ಇರುತ್ತೆ. ಆ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ ಸುತ್ತುವಂತ ಇಲೆಕ್ಟ್ರಾನಿನ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟಮ್ ಫಿಕ್ಸ್ ಇರುತ್ತೆ. ಆಮೇಲೆ ಅದರ ಡೈರೆಕ್ಷನ್, ಸುತ್ತುವ ಡೈರೆಕ್ಷನ್ ಕೂಡ ಫಿಕ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಇದಕ್ಕೆ ನಾವು ಸ್ಪೇಸ್ ಕ್ವಾಂಟೈಸೇಷನ್ ಅಂತ ಕರಿತೇವೆ. ಓಕೆ, ಸೊ according to Bohr's Sommerfeld theory, the orbits of the electrons are quantized with respect to their size and form. But according to quantum theory, the direction or the orientation of the orbits in the space should be quantized. Okay. Now, orbits in space, we need a reference axis. So how these orbits are oriented? To understand this, we need one reference axis. To specify this, we assume an electron revolving in a circular orbit is equivalent to circular current. Hence, it produces magnetic field. When external magnetic field is applied to the atom, the electron orbit should be oriented with respect to the applied magnetic field. According to quantum mechanics, the orientation or direction of orbits in space should be quantized. So in other words, it selects discrete number of possible orientation of the orbits. So this is known as space quantization. So as we all know, electron is a negatively charged particle. It is revolving around the nucleus. Charge when moves, it constitutes current. So it constitutes magnetic field. Hence electron constitute or act as a teeny magnet. When it is subjected to an external magnetic field, whenever any object is revolving, so when we subject to an external magnetic field, that electron, instead of started revolving around the nucleus, it starts revolving about the external magnetic field. That is the orientation of the orbits that it shows. Okay, next one is the concept of electron spin. Students, you all know the electron is revolving in its selected orbit around the, that is, nucleus. So that it is known as the orbital motion of the electron. But the concept of electron spin was introduced by Alan Beck and Goldsmith in 1926. According to their hypothesis, the electron spins about an axis of its own while it also moves around the nucleus of the atom in its orbit. In the sense, this is the orbital motion of the electron, then this represents the spin motion of the electron. Just like Earth revolves around the sun, as well as Earth spins about itself. That it is known as the spin motion of the electron. The electron spins about an axis of its own while it also moves around the nucleus of an atom in its orbit. Thus, electron in the atom possesses angular momentum due to orbital motion as well as spin motion. So this is known as total angular momentum, and this is also quantized. So the electron has two angular momenta: orbital angular momentum, that is revolving around the nucleus in a orbit, and the spin angular momentum, that is spin motion of the electron. So therefore, when we add these two, orbital angular momentum and spin angular momentum, it is known as the total angular momentum. Okay, the orbital motion and the spin motion of electron introduces two magnetic moments. Students, we know whenever a charge moves, it constitutes current, it constitutes magnetic moment. So therefore, electron act as a teeny magnet. So therefore, the orbital motion and spin motion of electron introduces two magnetic moments. The magnetic moment due to spin motion may be parallel or anti-parallel to the magnetic moment of orbital motion. In the sense, if the electron is moving in a anti-clockwise direction in a orbital motion as well as the spin motion in an anti-clockwise direction, then we say that both spin and orbital motion are parallel. Okay, if the electron revolve in an anti-clockwise direction in an orbital motion and spin motion is in clockwise direction, then we say that the spin motion and the orbital motion are anti-parallel. Okay, so therefore the electron has maybe parallel or anti-parallel motion. So these vectors are also quantized. Hence, the atom model is based on these quantized vectors. The atomic model is based on these quantized vectors, is called the vector atom model. Thank you.